Welcome to Revolutions, the show that examines the gear industry in depth. I'm Senior Editor Matthew Jaster with Gear Technology Magazine, and I'm here today to talk about hard finishing with Dr. Antoine Türich from Gleason. Welcome, Antoine.
Thank you. Thank you for inviting me.
Let's briefly discuss the challenges transmission manufacturers are currently facing in the automotive industry.
Yeah, especially the automotive industry is facing a huge system change away from traditional driving using combustion engines towards e-mobility plus autonomous driving, which is impacting the whole car architecture, which is impacting the whole drive chain, including finally the gearbox, which we are interested in. This will for sure not happen overnight, but however, the change is already ongoing. Nobody knows exactly how long this path will take, which path exactly to go, and more than ever, flexibility plays a very important role for, especially for the automotive industry and all the sub-supplies into this industry. That's pretty important.
Okay. How does hard finishing by grinding or honing provide suitable results in the auto industry?
So grinding, honing, hard finishing in general is absolutely mandatory to face the challenges especially for eDrive, because eDrive requires much higher input speed. Input speed compared to a combustion engine, maximum input speed in combustion engine is 6,000. On eDrives, it goes easily from 15, sometimes even 20, 25,000 RPM, so much higher input speed. Extreme noise requirements in combination with high input speeds is a real challenge. And what is missing is the masking noise of the combustion engine. So this is extreme requirements, and that is absolutely clear that this can only be achieved by implementing hard finishing technologies such as honing, grinding, and there is also a third alternative which is pretty interesting, which is hard power skiving.
Okay. Why don't we explain the advantages of Gleason's Combi-Honing system today?
Yeah, Combi-Honing is a trademark from Gleason about a very interesting honing process. So what it is about is in principle using two honing rings in one setup, and by having this capability, you can use it for quite some interesting applications. So the first application is you use this process to hone two different gears, either on one shaft or, for instance, more and more so-called step pinions are coming up, especially in eDrive applications. And you can hone the two gears in one setup. And about the step pinions, which I just talked before, nowadays they also require a special timing, a very tight timing, and that's unique with our solution, that we have the only solution to machine such gears, hard finish such gears in one clamping with an extremely good quality. While other solutions which are available in the market, they require two subsequent processes. For instance, grinding the larger gear and then honing the smaller one, but then you need two machines, you need two clampings, and this can never achieve such a good quality as doing everything in one machine and in one clamping. So that is the first application where Combi-Honing plays a very important role, and then there is a second one which is also pretty interesting. So I said you can use two honing stones in one clamping, and now we have the chance to use one honing ring specification and another honing ring specification on just one gear. So to achieve, for instance, super finishing. I'm sure you know about polished grinding. Polished grinding is a technology which has been developed some years ago to achieve super finished gears, and we have taken this idea of using a two-wheel grinding zone to apply in honing. Instead of two-wheel honing ring, we use two honing rings, one for, let's say, the conventional honing, and then the second one for polishing, with some pretty amazing results, which is able, and yeah, you could So therefore, Combi-Honing can also be used for, let's call it, polish honing. So pretty interesting applications are possible with this unique technology which we apply.
How else would you say hard finishing is evolving today and in the future?
Yeah, so at the moment the demand is rather weak. So due to the different challenges in the world, especially the automotive market is at the moment is weak now. This has multiple reasons which I'm not going to comment in detail here. However, as I said before, we at Gleason, we strongly believe in the need of hard finishing, especially for the upcoming challenges in eDrive applications. So we will continue to invest into all technologies, but especially into hard finishing such as honing, grinding, but also hard power skiving.
Okay.
So very important.
Okay. And then what hard finishing technologies will you focus on in the coming years?
So Gleason is claiming to be the total gear solutions provider, so we are not focusing on one technology only, as some other people do. We will continue to invest into all technologies with a special focus on hard finishing, as I said, grinding, honing, but also hard power skiving, which is a pretty interesting alternative when it comes to machining of internal gears, which is also very important for eDrive applications where they use planetary gearbox systems. Honing is an extremely important process for parts which which does not allow grinding due to interference problems. Honing is the dedicated process when it comes to extreme noise requirements, which is the case in these eDrive applications. But on the other side, honing is a pretty sensitive process, so it requires a very good pre-machining. So if this is not the case, grinding takes over, since grinding is a more robust process, and grinding also has some advantages over honing. For instance, with grinding you can machine the root area, which in some cases is also mandatory to achieve the required root bending strengths and stresses, or to control the in-process the bias. So that is pro for grinding. There are pros for honing. None of these processes are better. So each process has advantage and disadvantage. And as I said, there is a third one, which is hard power skiving. In addition to that, we will continue to invest into the technologies itself, but also into holistic solutions. And a very good example is our grinding display, which we have here at our booth here at MPT show, where we are showing a grinding machine, which is combined via a tailored automation solution with an laser inspection unit. It is a GRSL, we call it, has been introduced first time last year at IMTS. That is a laser inspection unit using optical technique instead of tactile technique to inspect all teeth, all profiles. Now for the first time we are also able to inspect for lead, pitch and runout, and this in an inspection time which is shorter or close to the grinding time. So with this we are now capable to do 100% inline inspection right after the grinding process, and this will be a total game changer because now we are able to do to have immediate feedback right after the hard finishing, which is very interesting technology. In addition, we are working on the prediction of the noise behavior using those data from the laser inspection to predict whether a gear which just has been produced will have a noise problem or not. And this is also a game changer because so far this is tested in the so-called end-of-line test, where the gear is already assembled in the gearbox. The gearbox is running through a noise end-of-line test, and if a particular gear fails on this end-of-line test, this obviously is very cost expensive because then it has to be disassembled and everything. And we are working on a solution to detect a potential noise problem right after we have finished the gear, and this is a pretty interesting topic. So overall, although the weak economy at the moment, I'm pretty thrilled about the upcoming future, and especially the technologies to be developed. Yes.
Well, thank you for joining us today. Stop by the Gleason booth to learn more about these technologies. And to learn more about hard finishing, go to www.geartechnology.com.